Good afternoon, everyone. Today is the session number 4 from the chapter of moving charges and magnetism, and the topic is motion of a charged particle in a combined external electric and magnetic field. So, here I have drawn one diagram in which I have depicted this velocity as v of this charged particle q, and this charged particle is moving under the influence of this external electric field, which is denoted by E, and this external magnetic field, which is denoted by B. Now here, both these two fields, that is the electric field and this magnetic field, they are perpendicular to each other. Okay? The electric field E is along the y-axis. This is the y-axis. The charge is moving along the x-axis with a velocity v, and the direction of this magnetic field, that is B, is along the z-axis. So here we will, you can see that the electric field and the magnetic field, they are perpendicular to each other, and these two fields are also perpendicular to the velocity vector, that is the velocity of the charged particle. So we know that the Lorentz force is given by F is equal to Q E plus V into V. ठीक है, ये this is the Lorentz force, and F is the total force which is acting on this charged particle, and this is the sum of this this is the sum of this Fe plus Fb, where Fe is the electrostatic force and Fb is the magnetic force which is acting on this particle which is moving on the x-axis. So now in this case we will try to find out the net force which is acting on this charge q which is moving along the x-axis. So यहाँ पर आप देखेंगे कि this velocity vector, that is what you can say the velocity of the particle, this charged particle which is moving along the x-axis, it is perpendicular to the direction of this magnetic field. ठीक है, इनके बीच का जो एंगल है वो 90 डिग्री है, they are perpendicular to each other. So the direction जो आपका magnetic force का, the direction of the magnetic force कहाँ होगा? It will be the direction of the magnetic force is, as we have already studied, is perpendicular to both the is perpendicular to the direction of v, which is the velocity of the charged particle, and b. तो ये जो फोर्स का जो डायरेक्शन होगा, द मैग्नेटिक फोर्स का जो डायरेक्शन है जो होता है, दैट इज परपेंडिकुलर टू द डायरेक्शन ऑफ द मोशन ऑफ द चार्ज पार्टिकल एंड द डायरेक्शन ऑफ दिस मैग्नेटिक फील्ड एज वेल. दोनों, so in this case the direction of this magnetic force क्या हो जाएगा? This will be pointing downward, that is along the negative y-axis. This is the y-axis, ये आपका this is so ये आपका negative y-axis हो जाएगा, ठीक है, and this will be directed in this direction, and this magnetic force is equal to क्या होगा? Q into V into B. इसकी जो वैल्यू होगी, and this magnetic force will be directed in the opposite direction of this Fe. अच्छा, Fe की जो वैल्यू है वो क्या है? नाउ यहाँ लॉरेंस फोर्स जो दिया हुआ है, दैट इज यहाँ पे हमने लिखा हुआ है, नाउ F इज इक्वल टू Q E है, और ये दिस इज द लॉरेंस फोर्स प्लस Q V इंटू बी, जिसको हम लोगों ने, दिस इज कॉल्ड द लॉरेंस फोर्स बिकॉज दिस formula or this derivation was given by this Dutch physicist by the name of this Lorentz, and इसको हम लोग बोलते हैं Lorentz force. Now in this case FE is acting along the y-axis, that is the positive y-axis. FB is acting along the negative y-axis. So if FE is equal to FB, अगर ये दोनों बराबर हो जाए, if the magnitude of this this electrostatic force is equal to the magnitude of the magnetic force, in that case this particle will move undeflected along the x-axis. That is, the charged particle will continue to move along the x direction without any deflection. So if in this case, if f is equal to b, then हमारा ये जो this is the what is QE? This is the electrostatic force, that is which is equal to FE. FE is equal to QE, and FB is equal to Q is multiplied by the vector product of V into B. So ये हम लिख सकते हैं कि in this case QE will be equal to Q VB. ठीक है ना? Or we can say that V will be equal to, it implies that V will be equal to E upon B. ठीक है? That is, if the charge is moving in a combined electric and magnetic field such that the force of electrostatic force, such that the electrostatic force is equal to the magnetic force, then the velocity of this charge will be given by E upon B, which is E is the intensity of the electric field and B is the magnitude of the magnetic field, and this charge will move undeflected along the x-axis in this case, in this example. ठीक है, ये तो पहला केस हो गया. सेकंड केस लेते हैं कि यहाँ पे एक Fe लग रहा है. The force of this the electrostatic force is acting in the y direction, in the positive y direction. The magnetic force is acting in the negative y direction. So if Fe is greater than Fb, so what will happen? This charge will be subjected to a net total force in the upward direction. ठीक है? क्या हो जाएगा? The total net force that is F will be equal to what? The total net force F will be given by F will be equal to QE minus QV into B. ठीक है? और आप इसको ऐसे भी हम लिख सकते हैं, ये Q को अगर हमने कॉमन कर लिया तो ये दिस विल बी रिटन एज दिस Q माइनस E माइनस Q ब्रैकेट में E माइनस द प्रोडक्ट ऑफ द क्रॉस प्रोडक्ट ऑफ V एंड B. So ये हम ऐसे भी लिख सकते हैं. Now this this magnetic force FB को हम कैसे लिख सकते हैं? FB is equal to Q V into B. Now in this case हम इसको क्या लिख सकते हैं? Q into FB is equal to Q into Q multiplied by the vector product of V into B. Now B जो है B, that is the magnetic field, that is the this intensity of the magnetic field B is given, can be also written in the form of, in the vector form. I can write it down, this B is equal to B into K cap. This is the magnitude of the this magnetic field, and K is the unit vector along the z-axis. That is, basically this K is giving you the direction of this magnetic field. So B in the this magnetic field in the vector form can also be written as B dot k cap, where k cap is the unit vector along the this z axis, or you can say that, and b is the magnitude of this magnetic field, and k is basically just showing you the direction of this magnetic field. अब हम this velocity vector को भी हम कैसे लिख सकते हैं? V can be written as v dot I cap, and I cap is the unit vector along the x-axis, so it is giving you the direction of this velocity vector. So FB जो है, अगर हम इसकी बात करें in the vector form can be written as like this, ठीक है? तो अगर हम इसको FB को I can write it down as B into this is the I have just written down the value of this this magnetic field here, and V का क्या हो जाएगा? V का हो जाएगा V ये into I cap, ठीक है ना? So ये हमारा हो गया. This is the magnetic force, and I have written it in the vector form. So ये क्या हो जाएगा? This will be equal to Q. Now the cross product of K and I. K is the unit vector, and I is the unit vector along the z-axis, and this is the unit vector along the x-axis, and the cross product of these two will give you will be equal to j cap, ठीक है ना? So हम इसकी जगह पे लिख सकते हैं Q VB j cap. That is this magnetic field B. Sorry, this magnetic force is equal to Q VB j cap. J cap is giving you the direction of this magnetic force. Now in this case now j cap is क्या है? J cap is the unit vector along the y-axis. So this magnetic force will be acting along the y-axis, and as per the right hand thumb rule, this force will be directed downwards. That's why I have written it here. I have just mentioned this FB in the downward direction, that is along the minus y axis. ठीक है? ये आपका पॉजिटिव, ये x एक्सिस पॉजिटिव होता है, ये आप इधर जाएंगे तो दिस इज द, ये आपका नेगेटिव हो गया, माइनस x हो गया. ये आपका इसी प्रकार से y है, दिस इज द पॉजिटिव y एक्सिस एंड दिस इज द नेगेटिव y एक्सिस. ये आपको O क्या, दिस इज द ओरिजिन. सो द क्रॉस प्रोडक्ट ऑफ K and I is equal to j cap, where j cap is the unit vector along the y axis. So the direction of this magnetic force will be along this y axis, and it will be pointing in the downward direction, or you can say it will be opposite the direction of the electrostatic force. ठीक है? So it implies that the Lorentz force will be equal to Q E. Here I have taken that Fe is greater than Fb. So if Fe is greater than Fb, then the Lorentz force will be equal to Qe minus Q Vb, and I will j cap. J cap means that the direction of this force, this is the Lorentz force, this, or you can say this is the total force which is exerted on this charged particle, and this is given by Qe minus Qvb bracket में j cap, where j cap is the direction of this net force acting on this charged particle. So this is how we calculate the net force or on a charged particle which is moving in a combined external electric and the magnetic field. तो ये हमारा एक आ गया, इस केस में आ गया. अच्छा, अगर if FB is greater than, अगर if FB अगर जो है is greater than FE, तो उस केस में हमारा जो F की वैल्यू क्या हो जाएगी? The Lorentz force, or you can say the total net force acting on this particle will be equal to, उस केस में क्या हो जाएगा? That will be equal to Q VB minus UE J cap. J cap क्या बता रहा है? This is the direction of this net force along the y axis. ठीक है ना? So yeah. So this is when this is when the magnetic force is greater than the electrostatic force. ठीक है, तो उस केस में ये हमारा आंसर आ जाता है. एंड in this way we find the net force which is acting on a charged particle which is moving in a combined external electric and magnetic field. So in the next session then we will be discussing about the motion of a charged particle which is we will be discussing the motion of a charged particle. That is, I'm just trying to show you here with an example here. Let us say this is the magnetic field. Okay, and here let us say up. Now this cross is indicating that the magnetic field is directed towards the plane, and here let us say this is the charged particle which is moving in this direction, let us say with a velocity v. So now इसका जो motion है it is perpendicular to the direction of the magnetic field. And now what will happen this that the magnetic force जो है ना which is perpendicular to both these to the velocity vector and this magnetic field, it will be directed in this direction, and this will be providing the necessary centripetal force for this charged particle to move in a circular path. So we will be discussing about this situation in the next lecture, and we will try to find out the radius of this circular path and some other different parameters also. So thank you very much for joining this session number 4, and hope to see you very soon.